Now we are going to create a model, an energy model, for our Genski family habitat house using Ekotrope. The first step, of course, is to log in to Ekotrope Raider. And once you're logged in, you're going to create a new project. You do that by clicking the New Project button at the bottom. We have to give it a project name and the address, which all we have is Western Avenue, Sheboygan Falls, Wisconsin. We don't have a zip code right now, but we need one to determine the weather station. 53085. Looks like Western Avenue falls in the 53085 zip code, so that was easy enough. We can go back and say 53085. We'll use the same one for weather, which is in Sheboygan County, so all is good there. The rater of record, builder is Habitat for Humanity Lakeside. Our model is the Genski model. We don't have a community or a lot number. Construction year, we're going to guess it's going to be in 2022. And it wants to know, is it an affordable development? Since it's Habitat for Humanity, it may be an affordable development, but we don't know that for a fact, so we'll just leave that unchecked. Next, we need to put in our utility rates. I have some electric rates out here, but I don't have anything for Sheboygan Falls, Wisconsin at this point, so I'm going to just put in a U.S. average. Natural gas, also use the new U.S. average, and this will be something that we need to collect before our final rating is completed. The residence type is already selected as single family detached. We have several of them that we could choose from if we wanted to, but that's the correct one. Our floors on or above grade is 1 floor. Conditioned floor area we calculated as 2790 square feet. Our foundation type is not slab on grade. We actually have a conditioned basement. And our number of bedrooms, looking at the plans, we see we have 4 bedrooms. We can click OK, and that helps us create our new project. So now we have a new project with the information up here. We can change that project info anytime by clicking the Project Info button. We can add any notes up here if we want to. Now we can put in a site photo if we want to have a photo of our project here. Now we need to build the house. In Ekotrope, you actually build your house by building your walls, your roof, your floors, putting in your windows. You build your foundation. And so you can grab anything from the component library and build it. And if you already have items in there, then you can use them. This is the library in Ekotrope. If you have building designs that are master designs, then you can just choose a design too. So you can create your design and save it and use that same design over and over for different HERS ratings. So what we're going to do is create our initial house design. We're going to click on the pencil, which is an edit icon, to edit it. And we can see we've got our general info here that we've already filled in. And if you have any questions on anything, there's these little question marks in the circles that are very helpful. So like if we hover over this one, we see that for floor number, the floor level in multifamily building on the front entrance of this unit. We don't have a multifamily building. That's for multifamily buildings, and this is not a multifamily building. This is a single family building. We have an unconditioned attached garage, so we're going to click that. We don't know anything about electric vehicle ready space, so we're not going to worry about that. And let's move on to our envelope. The envelope has us build the building starting at the base. So we're starting at the slab and the basement slab floor. And we can choose one of these types, or we can go to our component library and create a new type. So what we have, our foundation is 4-inch concrete on 2-inch foam with an R10. We have 1-inch XPS, uninsulated and uninsulated bare to choose from. So we don't want any of those. We want to add a new type. So we're going to click Add. And we're going to call this 4-inch concrete 2-inch foam R10. And it is bare. And our description is pretty much the same. Under slab insulation R value is R10. And we have wall construction type here, but it's not a wall, it's a slab floor. But what this is looking for is what kind of wall is going to be built on top of this slab floor. So it tells us here framing type of the external walls built on this slab. The framing is going to be concrete because there is no framing. They're looking for either wood or metal, and wood also has other, so we'll just leave that alone and let that be other. Our next question is the slab completely insulated? If it's completely insulated, that means it has insulation underneath and at the perimeter. And we have the same R value, R10, all the way around. Now, if you remember from our typical wall section in our plan, we saw that there is insulation on the outside of the foundation wall, and there's insulation under the slab, and the insulation on the foundation wall goes all the way down to the footing, which is below the slab, so we know that that perimeter insulation goes all the way around the slab, and it's going all the way up the foundation wall to the top, so it is fully, completely insulated. We're going to click completely insulated, and we don't have to answer any of the rest of those questions. So now it's showing that we have our slab. We're using the 4-inch concrete, 2-inch foam R10 bare. Our surface area of our slab is 1,395 square feet. The exterior perimeter we calculated as 153 linear feet. Exposed masonry area, again we can touch our question mark, and it wants to know how much area is not covered by carpet or finished flooring materials. That's going to be all of it. So 1,395 square feet. The covering R value, there is no covering, so it's 0. The floor is below grade. We can choose below grade or on grade. And it's enclosing conditioned space or conditioned crawl space. It's enclosing conditioned space. So that is our slab. And we just have the one slab, so we don't need to copy or anything. So now we go to frame floor, and we decided we do not have any framed floors, so we can skip that. We do, however, have foundation walls. I'm going to go down to the foundation wall. It wants to know what we have on the foundation wall. We do have 2-inch extruded polystyrene, 2-inch foam board. Height above grade, we don't know exactly what that is yet. We can use a default. We can use the 1.5 foot that they have on here, or we can say 1 foot. It looks like it's going to be pretty much covered. The section shows 8 inches, so let's go 1 foot. The depth below grade is 7 feet because this is 8 feet tall. Our exterior perimeter is just for this part of the foundation wall, which is going to be the ambient foundation. We decided was 129 square feet. And it's between conditioned space and ambient air. Now we have a second foundation wall that is to the garage. So we need to copy this, and that will give us all of the same stuff, except our perimeter is now 24 square feet. And it is between conditioned space and the garage ground. However, one of the Ekotrope things is that we don't have the choice for garage ground. We can do ambient or conditioned space. So what we're going to have to do now is remove this foundation wall. We can't put it there, and we'll just change our exterior perimeter to the entire perimeter of the foundation walls, which was 153 linear feet. So let's move on to above grade walls. Above grade walls, we also have 2 sets of walls. We have the wall to ambient, and we have the wall to the garage. So we can call the first one ambient, and its construction is going to be 2x6 R19. We have 2x6 R19 bats. I'm going to grab that. Our surface area of our wall to ambient was 1,032 square feet. Surface color is the color of the exterior wall. We don't know that yet, so that's something our field crew is going to need to find out for us. Our choices are reflective, light, medium, or dark. We'll keep medium for now. That is sort of a default. And then between interior and is it an exposed exterior, uninsulated unconditioned basement, insulated unconditioned basement, unconditioned attached garage, attic, or adiabatic. That's our only choices in Ekotrope. So we're going to say exposed exterior because this is our exterior wall. And then we're going to copy that wall because the garage wall is the same construction. So we can copy it and we can say this one is garage. Still going to be 2x6 R19. The area of the garage wall is 192 square feet. And this time we are to the unconditioned attached garage. So there's our above grade walls. Our rim joist, again we have two rim joist areas, one to ambient and one to the garage. So we can name this to ambient. Wants to know if it's a common rim joist or has other characteristics. Now, according to our specs, the rim joists are R19 just like the walls, so we're going to go ahead and add a new rim joist. We will name it R19 2x6, and the walls were 16" on center. I'm just going to copy that and put it in the description. I like descriptive names, so I just leave them at that. The R value will be R19 because the spat is not compressed, being in the rim joist, and we will save it. The surface area for the ambient rim joist was 129 square feet, and that is to exposed exterior. So there's our first rim. We'll copy that. We're going to say rim to garage. Keep the 2x6. Our surface area for that one was 24, and it is to unconditioned attached garage. Now we have our rim joists. Then we're going to work our way up the wall and go up to our ceiling or roof. In this building we have a sealed attic, so we're going to name this sealed attic. Our roof assembly type from our notes is truss 2x6 24" on center. They don't have the type of ceiling that we're looking for, so we are going to add it. With a sealed attic in Ekotrope, you only want to model the layer of the roof deck because that is where the insulation is. You're not going to model the gypsum ceiling that is at the floor of it. So what we want to do is edit on this and then we'll name it at the end. We can click on our exterior to see what they have right now. What they have right now is some cellulose loose fill. They have cellulose in the stud cavities, and then they have a gypsum interior because they're looking at just a standard attic. We don't want any of those. Well, that's not how ours is built. So what we need to do is take out this gypsum. We're going to take out this continuous insulation. We're going to add a new exterior, which is going to be a plywood OSB layer, which is correct. And it is continuous. The material is plywood OSB, 1/2 inch. So we'll just leave that as it is. We like that. That's fine. And outside the plywood OSB, we have roofing. So we'll grab this and we're going to name this roofing. Description will be roofing. The material is not plywood. The material is, we're going to go with asphalt shingles for the material. We can keep the depth at 1/2 inch. That's probably about right. And our asphalt shingles, it's telling us that it's got an R of 0.3. My R value chart shows me that it is 0.44 for asphalt shingles from the residential energy book, so I'm going to change that to 0.44 per inch and leave it at that. So now we have our asphalt shingles, we have our plywood decking. This is our cavity. And the cavity is not cellulose loose fill. The cavity is going to be foam. That's what we were told. So we're going to say foam cavity. It is the stud cavity. The material is foam. Spray foam. low density because it's open cell. High density would be closed cell. We want low density polyurethane spray foam. Our depth is going to be the depth of the entire cavity, which are 2x6s, so that's 5.5 inches on the cavity. Depth is going to be 5.5 inches. Insulation grade, this is going to be an assumption on your part. You need to create an assumption and decide what grade you want to assume. If this is for a program that only allows grade 1, then you would obviously assume grade 1 insulation. If it's just a standard build and you're not going to allow, and you know that your rater won't allow grade 3, you may want to just choose grade 2 to be conservative, just as an assumption, and then you will list that as one of the assumptions that you have made. And then we're going to put in the R value per inch, and the R value is R3.7. They got that right in the guess. The stud cavity itself is wood, and the wood is going to be 5.5 inches deep, because it's a 2x6, 1.5 inches wide. The spacing on the roof deck is 24 inches on center. And we'll go ahead and leave framing faction alone. You would override that if you had advanced framing of some kind or something like that. You could play with it. Okay, so that is our layer that is in the cavity. Now we need another layer of continuous foam. So we're going to name this layer open cell foam continuous. And it's continuous, and the material is our low density polyurethane foam. And our depth, we have a total depth of 12 inches. We just used up 5.5 inches in our stud cavities, so 12 minus 5.5, it leaves us 6.5 inches that is sprayed on top of our 2x6 trusses. So we have 6.5 inches. It is R3.7 per inch. And so now we should have our entire roof deck built. We've got our asphalt shingles, we've got our plywood or OSB, we've got our stud cavity with spray foam in it, and then we've got our continuous spray foam on the outside of that. So we've now built the ceiling and roof. We want to change the name to name it something that is much more accurate. And we're going to say it's a 2x6 truss sealed attic. And our description can be sealed attic 2x6 24 OC 12 inches open cell spray foam. Okay, we don't have a radiant barrier, so we can save this. When you're creating something new, you don't worry about the verified box. That is going to be checked by your library curator, as called in Ekotrope. Someone in your company who's in charge of the library and is going to review the information that you put in to make sure that it is modeled correctly, and then they will check it as verified and it'll show up as available on future models. We don't have a radiant barrier, so we're going to go ahead and save this. And we now have our sealed attic type taken care of. Next we need our surface area. And our surface area, we can see if we hover over the question mark, is to be the thermal boundary surface area. So if the attic floor was normally insulated, it would be the flat floor area. But if the rafters are insulated, that's the pitched roof area. We calculated our roof deck at 1,528 square feet. We don't know what the surface color is of the shingles, but it can be reflective, light, medium, or dark. Again, we're going to default to medium at this point. And it's between the interior and a sealed attic, which is unconditioned space. As far as we know, it's just going to be unconditioned space, so we'll keep it unconditioned attic. And then our attic exterior area is going to include the gable walls. So we had calculated our gabled walls at 188 square feet. So we have our 15, 28 plus 188. So our attic exterior is going to be 1716 square feet. Now that should remind you that we have not put in our walls for our gable end walls in our attic, and we need to add them. So I'm going to scroll back up here to above grade walls, and I'm going to add a new one. And this will be our gable ends. And they are going to be the 2x6 R19 bat is what we're assuming, because they are built like the walls. We don't know yet if they're insulated like the walls or like the attic ceiling. But our more conservative choice is the R19 bat, so we're going to go ahead and leave that there. Our surface area of the gable ends is 188 square feet. The color on the outside we don't know yet, so we're going to leave it alone, and it's between interior and exposed exterior. Now it's not between conditioned space, it's between the sealed attic and the exterior. But we don't have a choice to say what is on the interior, so we're just going to have to leave it as interior to exposed exterior. Ekotrope kind of limits some of your modeling options, and so you have to make some choices that may not exactly match the structure that you're modeling. Hopefully they will upgrade in the future to allow you to model these more interesting and different structures. So we now have our entire envelope modeled. We'll move on to fenestration. Now one thing that we should do, at least at every tab as we go through, is to save our project. So we can go ahead and just hit save by clicking down here and allow that design to get saved, which we would like to do to make sure we don't lose any of our work just in case the internet decides to burp. So we've now saved that house design, so let's go on into our fenestrations and take a look at our doors and windows and skylights. Looking at our plan, we can see that we have a door between the house and the garage. We have a door in the front at the covered porch, and we have a door at the back porch. So we have 3 doors in our plans that are located on the home envelope. We need to add 2 more doors, but first let's start with the first one. We have an opaque door. Our type, we can choose the type of door. We actually know what that is. Let's see, our door is a fiberwood door, R2.5. So rather than just saying generic door, I like to be a little more specific when I know what it is. So I'm going to add a new door, and I'm going to call it fiberwood, R2.5. And it's an R2.5, but this system wants to know the U factor. U is the inverse of R, so what we have to do is take 1 divided by 2.5 to get our U value. The U factor is 0.4 for this door. We're going to save that, and we now have a fiberwood door. And we should probably name our door to start with, actually, to tell us which door this is. It is an opaque door, but let's say front door. That'll help us in the future to know which door we were modeling. So the front door, it's going to be fiberwood. The surface area, it is on the plans as a 3068 door, which means it's a 3-foot door. It's going to be 21 square feet. We don't know what the color of the door is. And the wall assignment is which wall is it assigned to. This is assigned to the ambient, so we're going to leave that way. Our back door is the exact same door in the exact same location and everything, so we can just copy this and say back door. And then let's copy it one more time for our garage door. And it's not against the ambient area, it is on the garage. So there's our 3 doors. We have windows in the front, on the left, and on the back, and 1 little window on the right. We know that our front is facing north, so we're going to have our north windows. If we look at our elevations, we can see that all 3 of the front windows are underneath the front porch overhang. So they are all going to be shaded somewhat under that front porch. We can put them all together, or we can model them all separately. Since it's easy enough to make a copy, I'd suggest modeling them separately just in case they decide to make a change to one of those windows during construction. you can easily change the one window and not have to redo the rest of the windows. So I'm going to call this front. I don't like putting, I also don't like putting the direction in the name, because this plan might be reused and it might be reoriented, and what was a north window might now be a south window or an east window or a northeast window. So we don't want to put the direction in the name. We'll just call it, there's one in the dining room. How about front dining? Front dining window. We know our windows are vinyl, and they have a U of 0.30 and a solar heat gain of 0.33. So what we're going to do is choose to make a new one, because we don't have anything here that's going to match that. So we will add. I like to name my windows just by their U value and solar heat gain coefficient, so that it's very easy to know which ones they are. So I'm going to say U 0.30, S 0.33. I can say it's a vinyl. We can just copy this from our specs. And now we put in our U factor, because the system isn't going to be able to read our description. The system is looking in here to see what it is. So our U factor is 0.30 and our solar heat gain coefficient is 0.33. I'm going to save that. The surface area of that window, it's a 3060 window. So that is 3 feet by 6 feet. That is an 18 square foot window. The orientation is north. The wall assignment is the ambient wall. The window is operable. We can see that. If we look at our elevations, we can tell that the window is operable. So we're going to leave that as a default there. We do have an overhang of the front porch. The front porch is 6 feet deep, it looks like from our plans. So the overhang depth is 6 feet. To the top of the window, if we look at our elevations, it looks like it's pretty close to that porch roof, but we can't really tell, so I always default to 1 foot to the top, and then our field crew is going to tell us what it actually is. So if it's 1 foot to the top and it's a 6 foot tall window, it's going to be 7 feet to the bottom. The exposure we can leave as defaults. Adjacents, if we have any adjacent shading, which we don't see anything except the overhang. Adjacent shading is going to be parts of the building that jut out, permanently fixed awnings, decks, things like that, not including trees or bushes. Even though they're showing on the picture here, we don't include trees and bushes. So we're going to leave the adjacent shading as nothing, which is what this slider is right now. If we move it over, we've got some shading, but we're going to leave it as no shading right now. It's just open to the sun. And we're going to leave our interior winter and summer exposure alone, because if you change those, they will automatically change back for a HERS rating. Those are just the defaults that are going to be used to normalize this rating across the country. So leave those alone as well. So we now have our front dining window, and that is our first window. We need to add that a few times to have more than one window on the front. So we're going to copy, and this one, our new window, is no longer a front dining window. We have the front living room window, and this is our first window. So it's no longer a copy. Take that out. Let's say front living window 1. It's exactly the same as all the rest of it, so we're good there. We'll leave that alone. And we want to copy that. So now we are on front living window 2 copy. Living window 2, it's no longer a copy. 2. And it's going to be the same. So there's our 3 front windows. Then we have windows on the left. Go out my left elevation, and we can see these windows on the left are 3050. There are 3 of them. They're going to be the same U value in SHGC. So let's go ahead and copy our window and change it to left. And the first one is in the living room, left living window. It's going to be a 3033. Surface area, it's a 3050, so it's going to be 15 square feet. And now that I look more closely at our front windows, I see they are also 15 square feet. I thought it was a 3060, but it's a 3050, so we're going to need to edit them. But this orientation is east. Let's go ahead and pick east. We'll finish what we're doing here first. Our overhang depth now is just the 1 foot overhang. We're going to go ahead and leave it at 1 foot to the top of the window, and it's only a 5 foot tall window, so it's going to be 6 feet to the bottom. Now, as long as I'm thinking about it, let's fix these guys. We just click on it to edit it. And say this is 15 square feet and 6 feet to the bottom. 15 square feet and 6 feet to the bottom. And one more, 15 square feet, 6 feet to the bottom. So it's that easy. Now back to our left living window. We want to go ahead and copy that a couple more times because we have 2 of them. And it is not the living room anymore. This is bedroom 2. And everything else stays the same. And just to be lazy, I'm going to delete that other one I copied. I'm going to copy this one instead because then I don't have to retype as many words, and I'm now on left bedroom 3 window, which is the same. So that is our east window. So we're going to delete these other windows that it's stuck in here. Okay. So we have our front windows. We have our 3 left windows. We're going to have some back windows. We're going to copy our left bedroom window and make this one now as our back bedroom 4 window. And looks like I've forgotten to take off the copy stuff off of these. So let's take that off. It is also 15 square feet, only it is now facing south because it's on the back. And it's still on the ambient wall. Back elevation, we still have a 1 foot overhang. But we have more distance to the top of the window from the overhang. It's on a slanted roof. It's on the gable end part of the roof. So what we want to do is get the average height of the height above the window for the overhang. It's going to be about halfway through the window. We measure how tall that is. At halfway through the window, it's about 4 feet below the overhang. So the overhang to the top of the window is about 4 feet. It's a 5 foot tall window, so this is 9 feet. And that is our back bedroom 4 window. And then we have a back window in bedroom 1. So we're going to go ahead and copy this. We're going to call it bedroom 1 window. That's the master bedroom. Master bedroom's pretty much always bedroom 1. That's why I started it that way. We'll take out the little copy stuff. It's facing south. It's also 4 feet from the overhang to the top of the window, and everything else is good. So that's our 2 back windows, and then we do have 1 window on the left. Now the window on the left is a 3030 window. We'll go ahead and copy our last window because this window is going to have the same construction and everything else, only now we're going to call it left bathroom window. And it is facing west. And it's on the ambient wall. It's got a 1 foot overhang. Now we're back to 1 foot from the top. And since it's a 3 foot tall window, it's going to be 4 feet to the bottom, and our area is going to change. A 3030 is going to be 9 square feet. We now have all of our windows modeled. They're all on the ambient wall, and we are done with that. Then we go down to skylights. This house doesn't have any skylights, so we can just skip that. We finished our fenestrations. Let's go ahead and save our model. Moving forward to the Mechanicals tab. Our house does have heating equipment, cooling equipment, and water heating equipment, so we're going to leave mechanical equipment there. Now here's our folder of items that we found in our investigation into efficiencies. We've got our HRI certificate for the air conditioner, for the furnace, and we've got our information about the water heater right here. So I'm going to pull those up, and we can see for our heating equipment, we don't want a common minimum efficiency. We want to put in our own equipment and make it exactly how we found it. So we're going to add equipment. We can name it Goodman Furnace Goodman and the model number. And that way, if we run into the same furnace again, we can just pull up this item and we will know that it is correct. It's a furnace. The manufacturer is Goodman. The model number is GME. HR reference number is a nice thing to have, so we'll go ahead and put that in. We've got it. The fuel type of this furnace is natural gas, so it's going to leave it as forced air. It doesn't give us a choice to change that. The motor type, we saw on there, it's an electronically commutated motor, so we can choose ECM, variable speed. Our AFUE is 92.1%. Our output capacity is 74 kBtu per hour. And we can use the default EAE if we want to. That's generally if you're just guessing on the furnace. We have the actual EAE rating from AHRI, so we're going to uncheck that. And we're going to put in our EAE 478. And we can add a description now that tells us that this is a 74 kBtu H, 92.1 AFUE. Put a space in there. We got some space in this one. 478 AE gas furnace. There we go. Save that. And now you can see we have our Goodman furnace on here. Once our crew's been out in the field, it's a good idea to add the serial number to show that we were there and we saw it. This is the only furnace we have, so it's going to serve 100% of our heating load. And our location of our furnace, we saw that in our plans. It was down in our conditioned basement, so we can say it's in a conditioned space. Again, we want to add our cooling equipment. I'm going to name it just like the furnace, manufacturer and model number, and I'm going to put the condenser and the coil on here because the match between the condenser and the coil is what gives us the efficiency. This equipment type is an air conditioner. I'm going to go ahead and put in the model numbers from the AHRI certificate and our AHRI reference number. Distribution type is forced air. It's using the forced air ducts from the furnace. We have the SEER from our AHRI certificate as 13.5. And our output capacity, always have to make sure you're pulling output capacity, not input capacity. Cooling capacity for this is 22.2 kBtus per hour. The AHRI certificate shows 22,200, but it's looking at BTUs per hour. This is asking for 1,000 BTUs per hour, kBTUh. So we move the decimal point over and we put 22.2. Click Save, and we've got our heating equipment, our cooling equipment, and we need our water heater. So we have a water heater. We don't want a solar water heater. We're going to add our own water heater. Our name is going to be A.O. Smith. Equipment type is water heater. There it is, residential water heater. Manufacturer is A.O. Smith. We don't have an AHRI certificate for this one, so we'll just leave that reference number blank. It serves one dwelling unit, and it is natural gas, and it's providing hot water. So now we can choose whether we're looking at energy factor or UEF. We have the UEF, not the energy factor, so we're going to go ahead and put the UEF. This is 0.59. It's not tankless, so it wants the tank capacity. We want the rated capacity, not the nominal capacity. And on our information we found, the rated storage volume was 39. Put 39 on there. If you choose detailed inputs, then you can put in your input kBTUs per hour, which we have, so we can go ahead and put that in here. I'm going to say it's 35.5. We have the input as 35.5, but we don't have recovery efficiency. So I'm going to uncheck that box and let it use a default. And it wants to know if it's a solar hot water, what's the system type. It's not solar hot water, so we'll just leave that as none. And we save. And I forgot to put a description in there, didn't I? If we want, we can edit it and add our description. So then let's add our description, which is going to be 39 gallon 0.59 UEF. Tank, water heater. Save. Okay. So we have all our mechanical equipment. Our mechanical ventilation is not put in on this screen. This screen is only for heating, cooling, and water heating. So let's put in our distribution system. It's already got one in here because it knows that we have forced air from our heating and cooling systems. So far we're untested. We do have some targets that we are supposed to meet for our leakage to outside and our total duct leakage. So we can go ahead and click tested. We're going to go ahead and put that in there because we want to see what the rating is going to end up with once it is tested, if it meets that threshold. And we need to tie our ductwork to heating equipment and cooling equipment. So we choose our heating equipment. We only have one to choose from, so it's just going to use the one that's there. Total square feet served is going to be the total square feet of the entire house, which is 2,790 square feet. Our specs tell us that we have a central return, so we're just going to have one return grill in the whole house. And then we need the supply and return areas. So we can click estimate area, and it's going to estimate that based on all of the other information we've put into this system so far. Our ductwork has R0. There's no insulation, so we're going to say R0. R0. Our leakage unit is going to be CFM at 25 pascals. And we need to know what our leakage to outside and our total duct leakage was. So when we look at our specs, it's telling us that our target is 6 CFM per square foot, and then it has TDL next to it in parentheses. The 6 CFM per square foot TDL stands for total duct leakage. So our leakage to outside and our total duct leakage, our target is 6 CFM per square foot. We have 2,790 square feet. So if we were to calculate 6 times 2,790, we're going to get leakage of 16,740 CFM at 25 pascals. That is way out of our tolerance level. That's a lot of duct leakage. There's no way the ducts are going to leak that much. My educated guess would be that this is actually looking at 6 CFM per 100 square feet, and the per 100 just accidentally got left off of the information. So it's really going to be 6 CFM per 100 square feet. So what we need to do is take our total square feet, which is 2,790, and divide that by 100. Which is going to give us 27.9. And multiply that by 6, and we get 167.4 CFM at 25 pascals. That is what we are looking for. So we're going to say 167.4, and our total duct leakage test conditions would be post-construction, and it's going to be 167.4. We're just going to put the same number in both fields for right now. Now we have to say where our ducts are located, and our supply and return are both located 100% in conditioned space, according to our specs. So we're just going to leave the 100% conditioned space here, and then you see we have this use default flow rate. That box can be unchecked if we know what the design airflow is of the system. We don't know what the design airflow is, so we're just going to let you go ahead and use the default. We now have our ducts modeled. And if we were using HVAC grading, then we'd have a new section that would show up, and we'd be able to put in the HVAC grading. We don't have any information on that, so we're going to skip that. And then we're going to go to mechanical ventilation. We do have mechanical ventilation, so let's add a mechanical ventilation system. Our mechanical ventilation system is an ERV. So the ventilation type is ERV, and we found that information. Our manufacturer is Panasonic. The model number was F. Now it's asking about the energy recovery percent, and if we look at our information that we found from the HVI website, our energy recovery percent, it's going to be our total ATRE number. So it's either 66, 64, or 58. What is the difference there? The difference is that these are all based on different airflows. We don't know what the airflow is going to be yet because it hasn't been measured. So you'll notice that here it says check the quick results panel for ASHRAE 62.2 requirements. So we can find out over here what our ASHRAE 62.2 requirements are. What we're going to have to do is have this updated. Let's save first. We're going to save. Update our quick results panel. And we can go to our ASHRAE 62.2, which we now have enough information to decide. So according to ASHRAE 62.2 2010, we need 65.4 CFM, and according to 2013, we need 63.1. We're going to go with the most recent one available, 2013, and really 63.1 or 65.4 aren't much different. We can look back here and say 66 is going to be our closest number to what we need. So we can come back to our total ATRE, which is our total recovery efficiency, and that is 64%. So that's what we're going to use here. I'm going to say our energy recovery percent is 64. The flow rate can be measured. We don't know what the measured flow rate is yet, so we'll leave that alone. We can use the default fan watts, or we don't want to because we have information. We can take we can go back to our 66 and see that the watts, the power consumed for 66 CFM is going to be 32. So we want to say that we have 32 watts. And it's just running 24 hours. So operational hours is 24 per day. It's not intermittent, so we don't need to worry about that. So we uncheck that box. And we can go ahead and make our measured flow rate the same as our expected flow rate, which is 60. We were looking at 66. Let's go ahead and put 66 on there, which is what we found here. We found 66 airflow was our best, so we're going to use that. We'll make that our measured flow rate. And now we have our mechanical ventilation completed. We don't have a dehumidifier. We don't have to worry about that. We do have the opportunity for natural ventilation because our windows will open. We don't have any ceiling fans. We've been told that. And our climate control, which is our thermostat, is programmable. So we're saying it's a programmable thermostat. We don't have the make and model or serial number for that yet, so we'll just leave that where it is. And we are finished with our mechanicals. Let's go ahead and save. Let's move on to the water. We're being asked, what is our water fixture type? Is it going to be standard or low flow? And do we know anything about that? We don't have any specific information about our water fixtures and whether or not they're low flow, so we'll leave them at standard, which is the most conservative assumption. We can use our default hot water pipe length, or we can go ahead and put in our own. We already calculated our hot water pipe length, so we will undo this. And what we have is we've calculated 31 feet, plus we're going to add 10 feet for each conditioned level. We have the conditioned basement level, so we're going from the water heater up to the main floor, and 10 feet for the main floor. So it tells us here to add 10 feet of piping for each floor level, plus 5 feet for unconditioned basements. If there's an unconditioned basement, we have a conditioned basement. So we're going to go 31 plus 20, which is 51 feet. Then if we knew that our water pipes were all insulated, which we do not know, then we would check this box if they were at least R3. We don't have a hot water recirculation system, and we don't have drain water heat recovery that we know about. So we'll leave all that alone, and we're done with water. Moving on to lights and appliances. Our lighting, we were told that we have 100% LED interior and 100% LED exterior. So what we're going to do is say 100%. We're going to do detailed inputs because we don't know what's in the garage yet. We're going to say 100% interior LED and 100% exterior LED We're going to leave the garage alone until we know more. So we'll just leave it as 0. Our appliances, we were able to find that information as well. Our refrigerator, we found out our annual energy use of our refrigerator was 722 kilowatt hours per year. Our refrigerator is in conditioned space, so we don't want to check that box. Our dishwasher energy guide tells us that it is 270 kilowatt hours per year. 270. The dishwasher size, according to our energy guide, is a standard capacity model. The natural gas operating cost on the energy guide is $24 a year. The gas rate is $1.09 per therm. The electric cost is 12 cents per therm. All of that comes from the energy guide label. The dishwasher is in conditioned space, so we'll leave that alone. We don't know yet what our fuel type is for our range and oven, so we can leave it at the default of electric. We don't know if we have a convection oven or an induction stove, and we're pretty sure that the stove and oven is going to be in the kitchen, which is conditioned space. Our dryer is the one thing that we were unable to find any information on. So we're going to leave our clothes dryer fuel type as electric, and we are going to use the HERS reference for the dryer properties. We're just going to leave it alone as it is, which is using our defaults. We don't need to customize it. But our clothes washer, we do have the energy guide. So our clothes washer, we can go ahead and customize because we have all the information for that. Our labeled energy rating is 179. Our IMEF is 1.57. Our natural gas operating cost from the energy guide label is $12. Our washer capacity from the energy guide label is 4.3 cubic feet. The gas rate is $1.09. The electric cost is 12 cents. The loads per week, based on 6 wash loads per week, so that is correct. And our washer type on the California Energy Commission information we found is that it's a top load washer. It is in conditioned space, so we'll leave that alone. So we're done with our lights and appliances. Moving on to infiltration. Our infiltration rate, we have a target that we are trying to meet. We're trying to meet 3 ACH 50. So we have ACH at 50 pascals chosen. We want to go 3.0. Shelter class is, we can leave at the default, which is 4. And if you look here, you can see what the shelter classes are. 1 would be no obstructions. 2 is typical for an isolated rural house. 3 is typical shelter caused by other buildings across the street from the building under study. And 4 is basically typical for urban buildings on larger lots. 4 is typical. That is our default, so we're going to leave it at 4. And our measurement type is going to be blower door tested. So we know it's going to be blower door tested. We'll leave it at that. Let's go ahead and save. Our next tab is on-site generation, and we don't have any solar generation, so we can skip that one. Next is codes and programs. Whichever codes we might be going for and programs we might be going for, we would check them here if we need to. And then usage is if we wanted to have user-defined data for computing the energy usage, we would put that in there. We're not going to use user-defined data because we're doing a HERS rating, and the HERS rating is normalized, assuming that the house is going to be used the same no matter who's living in it. So we are finished. What we can do now is save. And we want to update our quick results to verify that we've gotten everything that we need to get for this rating. And we don't want to have any of these red exclamation points left. So we still have some. So currently we have a HERS of 57 and our annual energy bill of $16.61. So we need to open this up to see what are we missing. There was no rating date specified, so today's date is going to be used. Air infiltration, it's saying basically that we have to have a blower door test. So this is only because we're doing a projected rating, so we don't have a true air infiltration test that has been confirmed and completed. So we can go to the section and change it to blower door tested. Then we scroll down. See, our mechanical equipment location must be specified, so we must have missed putting mechanical equipment location. So let's go look at those two sections. We'll go back to infiltration and we'll go ahead and say blower door tested. And we'll go back to mechanical. And we did not specify for the cooling equipment or the water heater. So the mechanical equipment location for the cooling equipment is going to be the location of the coil. Coil is located in the furnace is located in conditioned space. So we're going to say conditioned space. And our water heater is also in conditioned space. It is down in the basement. So now, if we update, we are going to see that our HERS should change to a green check mark. Scroll back up. Now we just have our yellow. So our rating date wasn't specified. Now our rating date isn't specified in the initial house design. We go back to our Ginsky residence, project info, rating information, and here's where we would put our rating date. We're going to go ahead and put today's date in there. Save it. And now if we go back into our building design, it's recalculating automatically, and we see that we have a green check mark for HERS. So we have everything we need to have a valid HERS index. Our current HERS index is 57. One thing you may have noticed about Ekotrope as we went through is that it does pre-fill the screens and the fields with its best estimates based on the information that you put in for the project information. It does a guesstimate for you. It does a pretty good job. But one thing I like to do is just double check all of that and make sure by looking at the building specification summary and the building summary that everything that I thought I was putting in there actually made it into the model. So I'm going to click OK, and I'm going to scroll down and take a look. And we can check our area, we can check our volume, and what I'm seeing here is not our volume number. So I must not have input the volume the first time through. This is Ekotrope's guess, which probably does not include the volume of the sealed attic, and so we need to fix that. We'll take a look at that and fix it, and we'll scroll on down and see what we can find here. I always like to double check that I have gotten all the windows. We have the back, front, left. Where is our right window? Looks like we might be missing the right window, and also I don't see the foundation windows. I must have left the foundation windows off. That is a common error. So we will go back in and put in our foundation windows. We'll fix our volume. We'll check that right window. We'll come on down. We've got all three doors. The roof location is attic. That's between conditioned and attic in Ekotrope. It really should be between conditioned and outside air. So we'll fix that as well. I remember talking about that, and I must have said the wrong thing. It's not to the attic. It is between the attic and the outside air, but our attic is a sealed attic, so it's also called a conditioned attic. It needs to be, the location here is for the other side, not the conditioned side, so that needs to be outside. And then keep scrolling, just take a good quick look. Our lighting looks good. We don't have any on-site generation. And let's look at our equipment. And look at my equipment details. Oh, and so this is popping out at me. It looks like we've got our ECM motor on our furnace, but we did not change our motor for our air conditioner. The air conditioner is using the furnace motor to move the air through the distribution system, so it's also an ECM motor, and that needs to be fixed. So as you do more and more of these, you'll get better and better at having these things pop out at you and seeing what it is that you might have missed. Clothes dryer, dishwasher, appliances, and controls. It all looks, all of the rest of that looks good. So we have a few things to fix. I'm going to go back to the Ginsky residence. We can just click on our breadcrumb trail right there and go in. And go back to our house design. And we'll see if any of these things change our HERS index number. We know our HERS index is currently sitting at 57. We want to change our volume. And the conditioned volume that we calculated was 28,121 cubic feet. We want to check our windows. Oh, here's our right window. It's called left bathroom window, so maybe we just fix the name of that. That should be right. Bathroom window. And we do need to add our foundation windows. So I'm going to add a new window. This is going to be back foundation window. Our foundation windows are glass block windows, and they have a different U value in SHGC, so we need to add another type to our library. The U is 0.68, and the SHGC is 0.55. Always remember to also put these values inside the fields inside your library item, or your system will not know what to model. And save. The surface area of these windows, let's see, on the plans they show 32 by 16 glass block. Now that could be 3 foot 2 inches by 1 foot 6 inches, or 32 inches by 16 inches. The nomenclature is different than on the main level, and usually the nomenclature on all the levels for the windows will match, and sometimes it'll be written on the plans showing you whether those numbers are feet and inches or just inches. So I measured this window with my architecture ruler on the scale drawing, and it is 32 inches by 16 inches. So to convert inches to square feet, we're going to multiply the inches together, 32 inches by 16 inches, and that gives us 512 inches. Then we divide that by 144, which is 12 inches times 12 inches, and that converts our square inches, 512 square inches, to the right number of square feet. 512 divided by 144 equals 3.5 repeating. We are going to take our inches to the nearest tenth of a square foot, so we're going to call that 3.6. The orientation of that back glass block window is south, and it is going to be assigned to a foundation wall, so we want the foundation wall for that. Now these windows are so far below the overhang that they will never be shaded by it. We can leave all of these fields as 0 because the windows won't be shaded by the overhang. Since these are basement windows, they might be in a window well, and if they're in a window well, they will have some adjacent shading that is permanently there. But looking at our elevations, it looks like they are right up at the top of the foundation wall and they are above grade. So we're going to leave this as no adjacent shading, but we'll make sure our field crew lets us know if there are window wells, if we need to add adjacent shading to those. We'll go ahead and copy that to make our other foundation window, which is on the left. So it's going to be a left foundation window. It's going to have the same U value and solar heat gain coefficient. It's going to have the same surface area. It's also 32 by 16. It's going to be facing east. And it's on the same wall. So everything else can stay the same. And we now have all of our windows. Okay. Our next item was our mechanical. We wanted to make sure that our cooling equipment took credit for the ECM motor. So we're going to edit our cooling equipment, and we just need to change single speed to variable speed. Save that. And we skipped the envelope. Let's go back to the envelope. We need to fix our ceiling, our roof. Ceiling and roof, what we want to do is say this is between interior and exposed exterior, because it is a sealed attic, so it's between the attic and the exposed exterior. Okay, so we've made all the changes that we knew we needed to make. Let's run and, well, let's save to start with, and then we'll update and see what happens to our 57 and our 1,602 energy bill. Update. We raised by 1 index point, and our energy bill changed. Now, the other thing you can see up here at the top are these tabs. We could also have gone to areas, and we could have seen that our conditioned volume was incorrect at that point in time. We can take a look at these and see if they make some sense for us. If we had added together all the areas of our windows, we would have known that we must have missed some windows, things like that. So we can also see windows by orientation. We can see all the different areas of things. You can click the Energy tab and see what your costs are, your bill breakdown. It's showing how much everything is costing, and what the percent load is based on the way that we modeled it. And notes, of course, houses all of the notes that we have been collecting as we have been working our way through the project. So let's save and close. And we now have a completed HERS rating. After all of that, you deserve a nice long break.